right, this is your Unit 1 review video. We're going to start out here with the first few problems, and notice in the directions it says for questions 1 through 3, use the graph below. Starts out right there with number 1. Okay, we get a graph and we get a basic simple question. It says, what function family does this graph belong to? We have to remember what our 3 function families are: linear, exponential, and quadratic. Linear being straight line graphs, okay? Anything from positive increasing, negative, constant functions, decreasing, maybe a constant function. All of those are examples of linear graphs. Our exponential graphs, those are our acceleration type of graphs. Those are that's what some of you called them this year, okay? They look like elbows. Okay? There's a lot of different ways they can go. They could be flat on this side and then curve down. Lots of different ways. Those are our exponentials. Okay, look like an elbow. And then finally, our quadratic graphs. Those are our U-shaped graphs. Sometimes they're inverted. Okay, sometimes they look like this. Other times they look like that. Okay, there are quadratic graphs. And very clearly you can see that this function family here is a quadratic. Okay, but we're going to use that for the next couple of problems. So we go down to over to number 2. It says, which of the following best describes the behavior of the graph? Well, you have to remember, we always read graphs from left to right, just like we would read a book, okay? So we want to know if we start on the left edge of this graph and start moving to the right, where is it going? Well, we can see it's going uphill. To move to the right, we got to walk uphill, walk uphill, walk uphill. That is otherwise known as increasing. Then when we reach this very highest point up here, otherwise known as the maximum, we'll later learn to start calling it a vertex, we start going downhill. And downhill is known as decreasing. So we're looking for the option that says that, and that is option D. Increases, then decreases. This one's backwards. This one says always increasing. That would be like a linear increasing function or an exponential increasing. Always decreasing looks like that or like that. The only one that does both are our parabolas, and we were looking for the one that increased then decreased. Number 3, which of the following is true about the graph? It is blank and has blank. We'll see the first stipulation is continuous versus discrete. That's an easy one to decide, so let's start there. It is continuous. Continuous means it's a solid line with no breaks in it. So that takes out option C and option D, leaving us with just A and B. So it has either vertical symmetry or horizontal. The type of symmetry is deemed by what type of line you draw to cut it in half. And to cut this in half, we have to draw a vertical line right down the center of it. Okay, it's not a very good vertical line up here, but bear with me, you get the gist. A vertical line right down the center of it. That means it has vertical symmetry. It's that simple. Okay? Vertical line, cut it. Vertical symmetry. Number 4 is where we break away from that initial graph. It says, is the following a function? Explain your reasoning. This is the only problem towards the beginning that has an open answer. Otherwise, it's a lot of multiple choices until we get to equations. So this is so that I know you're not just guessing. Otherwise, you could just put yes or no and hope to get your points. Explain your reasoning. Whenever I'm looking for a function, I'm hoping to see no repeating x values. Okay, that's what makes something a function, being able to pass the vertical line test. Because if something repeats x values, that means it fails the vertical line test, having an x value of the same number twice. So that's what we don't want to see. Okay, well, we're looking. -3, 0, -1, 3, -1. Uh-oh. There's a repeat. So in terms of this being a function, is the following a function? No. Okay, but that's not all. You can't just put that. It's not going to be full credit. It has repeating x values, or it has x values that repeat, whatever, however you would like to phrase it. You could even put, thus it would fail the vertical line test. Make sure you just describe. Tell me what you know. Show your knowledge off there, okay? We get back into our nice comfort zone of multiple choice with number 5. Which of the following is a function? I had some people earlier that thought I needed you to name on every single one of them, okay? This one says is a function. You might have one tomorrow that says which is not a function. That would be a very common switch I'd make for a test. So which is a function? Well, we look at option A. I can draw a vertical line and it hits it twice. This is a non-function, which is not what we want, okay? So we eliminate option A. Option B. That's a linear function, we think, but it's kind of hard to tell. It looks like it is slightly slanted across the little bit of domain that we can see. Okay, looks like it's a little down here towards the left, and then by the end, it's up and toward a little to the right. So it looks slightly slanted. Let's move on though, because we can clearly tell that C is a non-function. It hits twice. Every vertical line we want to draw is going to hit twice. And then we get down to D, and D also looks like a nice linear function, but we notice D is perfectly straight up and down. Here's the trick, guys, and this is partly just a definition. If I draw a vertical line that hits that, not only does it hit it, but it hits it and hits it and hits it and hits it and hits it. It hits it actually an infinite amount of times, all right? Hits an infinite amount of times. So that one is definitely out. Meaning that first option we looked at, option A was out. That second option we looked at, option B, right here, that actually is enough of a slant. It's going to be hard to tell, but if I draw a vertical line down this, well, that's really hard to tell if I do it that way. If I draw a vertical line, it's only going to hit one time. Yes, it looks like it hits it for a really long time. You've got to realize there's going to be a very, very zoom in finite point where that crosses and hits it only one time. Plus, we kind of just did that one with the process of elimination. We looked at all the other options, and the only one that really could have been the answer was B. Number 6, describe the function as an absolute maximum or minimum, maximum, both or neither. Guys, it's a graphing problem, okay? We go into our calculators, we clear out whatever is there. We're looking for parenthesis, -3 plus x, close parenthesis, squared symbol. You can do that with the caret and the 2, or you can just press this little squared button. Make sure you arrow out of that so that we can put a -1 on the end. And then double check. Okay, I'm going to line them up. -3 inside the parentheses, plus x, got it, close them off, square it, got it, and then -1. Again, I don't care about that. There we go. Again, there's 2 ways to look at the graph. One, you can just press the graph button, but let's say the person before you really messed it up. Let's say they got this really crazy window going. I like to press zoom and then this 6 button, which gives me zoom standard. Now we're just waiting to see the graph pop up. Oh, it's a parabola. That's what I would have expected considering it had a squared piece. And we can see this goes down and down, hits a finite minimum point, and then goes back up. So we're looking for the answer that has just minimum, absolute minimum. Didn't have a highest point, didn't have neither, obviously had a minimum, and it didn't have both. Absolute minimum is the one we're looking for there. Number 7, this is our easiest evaluate problem. We're given f of x equals -2, parenthesis, x plus 1, close parenthesis, -4. But we don't want f of x anymore. We want everywhere that there was an x for us to substitute in a 4. There's only one place like that. It's inside those parentheses. So we have -2. Right here we have a 4 is getting plugged in. Normally I would do that with parentheses, but when I start doing like double parentheses like that, it really confuses people. Okay? So just be careful. I plug in a 4 and then I put -1. 2 ways you can do this from here. You can go ahead and distribute, but I wouldn't. I would follow our PEMDAS rules and I would clean up the inside by combining like terms. Again, -2 times a +5 is -10 -4. Giving me -14 as my answer.